Okay, so we've got an update here. We have updated a couple of things. We have the Arduino controller, and that's still running off of our 12-volt battery there. We've updated the combustion chamber design. We're not, at this point, we're just testing out the combustion chamber. We're not testing out the whole thing. So right now we're focusing on the electronics and control over the fuel. So we have fuel supply. We're going to use metered fuel now. We're going to electronically control the fuel. And we have, this is actually a readout of the pressure of the fuel. And it's actually just running off, using the Arduino is simply a 5-volt supply to read that pressure. We've actually already updated the code, so the USB here is just sitting there. We also have, this one's actually going to be a temperature. We're not actually integrating that yet, but eventually we'd like to integrate that into the engine control process. These are just LEDs. They're simply to show, to stand in for the eventual opto-isolated relays. Now here is my opto-isolated relay board. I got this off Amazon for a couple bucks, and it came with no documentation, so I had to figure out that I've got my positive supply here and my negative there, and then the 8 inputs. And in theory, this should interface directly to the Arduino. Now, ideally, what I would like is simply to have my LED actuated blocks, and these are actually DC relays. I would actually prefer my SSR to be triac, to be opto-isolated triac. But, you know, for a couple bucks, what can I expect? So this, I haven't actually hooked this one up yet, but it should hook up, and this does actually have LED indicators for each opto relay, so that should be good. Now, over here, I haven't actually, like I said, I'm just using the LEDs as a stand-in. So let's go over the code real quick and see what that does. So I've got my the first of course is the hold on, let me get that back here. First, of course, is our setup block, and we essentially establish all of our easily amenable outputs. We set the pin modes. Then we go into our main code section here. In our main code section, the first step is we're going to turn on the air intake fans, and then we're going to pulse all the spark on, because we're going to have 3 combustion chambers, and then those are going to be sparked on for 50 milliseconds, then off for 75 milliseconds. The reason for that is to charge the, or I should say not charge, but introduce some ozone into the combustion chamber, because ozone is O3, and of course that will assist in the combustion process. So then after it introduces some ozone, we kick off the high voltage supply, and we allow the fans to run for an additional 100 milliseconds to circulate the ozone and the air a little bit and get that homogenized inside the combustion chamber. Then we are going to put 300 milliseconds of fuel in there, but we actually delay for 330 milliseconds because the solenoid valve has about a 30 millisecond latency, so it doesn't instantly open. It takes about 30 milliseconds for it to open, and then we allow another 30 seconds for the relay to close. Then we are actually into the part where we ignite the chamber, and we basically run 2 cycles here. We pulse it on, we pulse it off twice, and that's the end. That's basically it. That is our ozone priming engine start code. So let's go ahead and flip it on and see what we got here. And as you can see, it's a fairly short cycle, and what I just want you to notice here is there's this red LED right there, and when that one goes, you notice that everything else is shut off. So that red LED is representing the fuel that is being introduced into the chamber. Now these three, you'll notice that these three flashing LEDs across here, this green one and this yellow one here and this other yellow one there, those are representing the spark. So that's your ozone generation and your ignition.